Thanks for clicking. Welcome to another Knowledge Math production. Today we're going to be talking about the Pythagorean theorem and the distance formula. So two things that you learned back in shapes class, I imagine, okay, that talk about the Pythagorean theorem for a right triangle, how to find the sides, as well as the distance formula, how to work with the distance, find the distance between a segment, distance of a segment if you're on the coordinate plane. All right, so let's get started. So let's start with the Pythagorean theorem. The Pythagorean theorem says the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Very fancy. Okay, so if this is my right angle, all right, the legs are attached to the right angle and the hypotenuse is always across from the right angle. My hypotenuse is always across from the right angle. So the Pythagorean theorem says the leg squared plus the other leg squared is equal to the hypotenuse squared. Okay? Now, you probably learned it as the leg is A, the leg is B, and the hypotenuse is C. You may also know it as A squared plus B squared equals C squared. But you have to know which one is C. That's what's most important. C is this hypotenuse. It's always the side across from the right angle. So you need to know that. You want to use this equation. You certainly can, but you need to know which of the three sides appears on its own on the right side of the equal sign. Okay? And that one is the hypotenuse. All right? So make sure that you know that. Okay, so here's an example. I have a rectangle that has a diagonal that measures 26 meters, and one side of the rectangle measures 24 meters. I want to know what the perimeter of that rectangle is. All right, so here's my rectangle. There's a diagonal that goes through the rectangle that's 26 meters long. This is a right angle here. One of the sides of the rectangle is 24 meters long. Now, it doesn't matter which side I label as 24. It doesn't make a difference. Okay, but one of the sides of that rectangle is 24. I want to know the perimeter of the rectangle. So you got to remember, how do I find perimeter? Perimeter means add up all four sides, right? 1, 2, 3, 4. Not this diagonal. That's not part of the perimeter. Just these four sides. So I know this side over here is going to be a 24, but I don't know either of these sides. So I'm going to have to try to figure them out. So I'm going to call this side X, just to call it something. But now, if I look here, inside of my rectangle, there is now a right triangle. And that right triangle, we can use the Pythagorean theorem on. So we know 24 squared plus x squared is equal to 26 squared. Now we got to do some math. So 24 times 24. 4 times 4 is 16. 1 to carry. 4 times 2 is 8. 1 more makes 9. 2 times 4 is 8. Times 2 is 4. So 6, 7, 576. So this number is 576. Plus x squared equals 26 squared. Now we got to do that. 26 times 26. 6 times 6 is 36. 3 more. 12 and 3 make 15. 2 times 6 is 12. 1 more. 2 and 2 is 4. 2 times 2 is 4. 1 more is 5. So that's 676. 676. So now we're trying to solve for x. So we're going to subtract 576 on both sides. We have x squared equals 100. Now, you need to remember how to get rid of this square. You can do that by doing the square root. Square root of x squared is x. The square root of 100 is 10. Hopefully you know that. So that makes this side 10 meters. That makes this side 10 meters. And this side is 24 meters. So now to find the perimeter, I got to answer the question. What's the perimeter? The perimeter is 10 plus 10 plus 24 plus 24. Right? The perimeter of the rectangle. So that's 20 plus 24 plus 24. So that's 44 and 24, which is 68 meters. And there's my answer. Okay? So it's not just using the Pythagorean theorem on its own. It's using the Pythagorean theorem a lot of times to do other stuff. Okay, that's what you're going to be faced with. So here's another example. Okay, the diagram shows the cross-section of a building. So the cross-section is if you cut into a house, what does a piece of that house look like, right? What does the side of it look like if you cut into it? This is what it would look like, okay, if you cut into it. All right, what is the area of the cross-section of the roof? So here's the roof. The area of the cross-section, that's a triangle. The area of a triangle is 1/2 the base times the height. So now I got to find the base and the height. I don't know what either one of them are. Well, I don't even know the hypotenuse yet, but I do because I know this side is 12. So that makes this side, it looks like it's a square there. So that side's 12 as well. So I don't know how much this side is. So I'm going to call it R for rafter. Why not? Okay. So if I call that R, now remember, these marks mean that these two sides are actually congruent, right? They're equal to each other. They have the same measure. So if this side is R, that makes this side R. And now I'm going to use the Pythagorean theorem to figure out what R might be. Across from the right angle, this is the hypotenuse. So I'm going to do R squared plus R squared equals 12 squared. So I'm going to combine these like terms. That's 2R squared. 12 squared is 144. So I'm trying to solve for R. I'm going to divide by 2 on both sides to get R squared by itself. It gives me 72. And now I need to knock out the square, so I got to do the square root. So I get R equals square root 72. Okay, so I'm going to leave it like this because I can't use a calculator. So I'm going to leave square root 72. And there's a reason why. You'll see in just a minute. But I don't want to know what R is. I want to know what the area of this triangle is. So the area formula is 1/2 the base times the height. So this one's also square root 72. So the base measures square root 72. The height also measures square root 72. So now, square root 72 times square root 72. The square roots knock each other out. That's why I left it there. And gives me 72. Half of 72 is 36 square meters. That's the area of the cross-section of the roof. Okay? So you can see what we're doing. We're using the Pythagorean theorem to answer other stuff. All right, so the distance formula. The distance formula determines the length from one point to another on the coordinate plane. So let's say here's my coordinate plane. Let's say I had 2 points. And a point there and a point there. I'm going to call this point x1, y1. And I'm going to call this point x2, y2. And I want to know how far it is from there to there. Okay? So what we're actually doing to figure out the distance formula is this is what we're doing. So I'm making a triangle out of this. I want to know how far it is from there to there. So what I do is I actually make a triangle out of this thing. It's a right triangle. And I use the Pythagorean theorem. Okay? The distance between this point and this point is the two y's subtracted. It's y2 minus y1. The distance between these 2 points are the x's subtracted, x2 minus x1. And now I'm using the Pythagorean theorem. So I know this side squared, that side squared equals the hypotenuse, I'll call it h, squared. So I have x2 minus x1 squared plus y2 minus y1 squared equals h squared. To solve for h, I take the square root on both sides, and I get the square root of x2 minus x1 squared plus y2 minus y1 squared equals h squared. Whoops. y2 minus y. All right, that's a mess. Let's fix this. There we go. y2 minus y1 squared equals h. And this is the distance formula. Okay, that's my distance formula. All right, write that down. Make sure you know it. Okay, make sure you have it written. You're going to need it. All right, let's calculate the distance between these 2 points. Negative 4, 3. 1, 2, 3, 4 to the left. 3 up. That's negative 4, 3. And then 1, 2, 3 to the right. 5 up. So I want to know how far it is from here to here. All right, so I'm going to use the distance formula to do it. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now you might be saying, well, do I have to know this? Yes, you have to know it. They're not going to give it to you when you take that college placement exam. They're not going to tell you what the distance formula is. You have to know it to be able to get it right. All right, so now I'm going to label these points like I did for slope. x1, y1, x2, y2. And I'm just going to plug them in. So x2 is 3 minus x1 is negative 4 squared. y2 is 5. y1, 3 squared. So that's going to be the square root of, these two negatives make a positive. So 3 plus 4 is 7 squared plus 2 squared. So that's the square root of 7 squared is 49. 2 squared is 4. That's the square root of 53. Okay, that's my distance. That's the exact distance. Now you can approximate it if you had a calculator. In some cases, they'll let you use a calculator. All right, but the square root of 53 is the exact answer. That's how far it is from here to here. This distance is the square root of 53. That's what we just found. Okay, let's graph the points and find the perimeter of the shape. All right, so first thing we got to do is graph some points. We got to go left 5, up 1, make a point. Left 1, up 1, make a point. Left 1, down 4, make a point. Left 4, down 4, make a point. Okay. So we got this side. Here it makes a shape. Makes a quadrilateral, right? 4-sided figure. There it is. Okay, now I got to find the perimeter of this shape. So I want to know how much it is if I add all around 4 sides. All right, so first things first. Some of these sides, they're horizontal and they're vertical, so they're easy to count. We just have to count how far it is. So it's 1, 2, 3, 4 boxes. This is 1, 2, 3, 4, 5 boxes. This is 1, 2, 3 boxes. Okay, that's easy. But this side is diagonal. So we can't just count the boxes, and we can't find the slope. We're going to actually have to figure out how far it is from this point to this point. So this point over here is negative 5, 1. And this point down here is negative 4, negative 4. Okay, so we're going to have to use the distance formula with these 2 points. So we have negative 5, 1 and negative 4, 4. Negative 4, negative 4. So x1, y1, x2, y2. My distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. It's the square root of x2 is negative 4. Oh, I'm sorry. X2 is negative 4. X1 is negative 5 squared plus y2 is negative 4 minus y1 is 1 squared. Whoops. So now 2 negatives in a row make a positive. So now we have negative 4 plus 5 squared plus these 2 signs are the same. So I add their numbers. 4 and 1 make 5. Take the sign of the number. That's a negative 5, and we're going to square it. Over here, these 2 signs are different. 5 minus 4, that's 1 squared plus negative 5 squared. 1 squared, that's 1. Negative 5 squared, negative 5 times negative 5 is 25. That's the square root of 26. So now my perimeter, so this side square root 26, is 4 plus 5 plus 3 plus square root 26. So now you got to remember some rules about square roots. You can add the 3 whole numbers, so that's 12, but then I can't add the square root to that unless I had this as a decimal. So my perimeter is 12 plus square root 26, all right? And that would be my answer. All right, hang on one second. I got to go back real quick. I just got to make sure I did not. What did I do? Oh, I put the X's where the Y's were. Okay. All right. Well, oh, no, I did it right. Okay. Never mind. Sorry. Let's keep going. I'm losing my mind here, folks. We got -5, -1, -3, -3. We got 3, 3. And then we have 1, 5. We want to find the area of this rectangle. Okay, to find the area of the rectangle, it's equal to the length times the width, or the base times the height. So let's see. We'll call this the base. We'll call this the height. I got to figure out how far it is from there to there, and then I got to figure out how far it is from there to there. All right, so I got to use the distance formula to do that. So for the base, let's write B for base. We're going to use -3, -3. That's this point. And then we'll use this other point, 3, 3. We got x1, y1, and then x2, y2. So my distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, here we go. x2 is 3 minus x1 is -3 squared. y2 is 3. y1 is -3 squared. So my distance is 2 negatives make a positive. 2 negatives make a positive. 3 plus 3 is 6 squared. Plus 3 plus 3 is 6 squared. So that's 36 and 36, which is the square root of 72. So this side is the square root of 72. Now for the other side, 3, 3, and we have to use 1, 5. All right, so let me come over here. Let's see if I can fit it. We got 1, 5 and 3, 3. x1, y1, x2, y2. Okay, I'm not going to write the formula down. I'm just going to plug the numbers in because I'm running out of room. So we got x2 is 3 minus x1 is 1 squared. y2 is 3. y1 is 5. It's the square root of 2 squared plus -2 squared. 2 squared is 4. -2 times -2 is +4. That's the square root of 8. So now the area is the square root of 72 times the square root of 8. Now when you multiply square roots, you can multiply the numbers inside the square roots and keep the square root. So we're going to do 72 times 8. 8 times 2 is 16. One more. 8 times 7 is 56. One more, 57. The square root of 576. Okay, now the square root of 576, I think it's 24. It's either 24 or 26, because I think we did it on a bunch of slides ago. 8, 4, yeah, 576. So the square root of 576 is 24. So that is my area, 24 square units for this rectangle. And that's it. So we're using the distance formula, we're using the Pythagorean theorem, but we are using them to do and solve other problems. Okay? As always, thanks for clicking.